This video is on solving a system of nonlinear equations. So in this case you have either one equation or all equations of the system to be nonlinear. So we could say at least one of the equations is nonlinear. That is, it is not of the form y equals mx plus b. Let's take an example. So for x, 2x minus y equals 7, x squared plus y squared equals 2. Just by looking at these two equations, the first equation is linear. The second equation, however, is not linear. It's actually the equation of a circle. So how do we solve? So again, it's by substituting one in terms of another. So let's start by using the linear equation, which is the easiest. So I'm going to rewrite y as 2x minus 7. I will take this y and plug it in the second equation. X squared plus 2x minus 7 squared equals 2. I will FOIL 2x minus 7 squared, I'll get 4x squared minus 28x plus 49 equals 2, which would give us 5x squared minus 28x plus 49 equals 2. Now I could use the quadratic formula. A is 5, B is negative 28, and C is 49, which would give me minus of minus 28 plus or minus square root of B squared, which is 28 squared minus 4 times A times C. A is 5 over 2A. So I will have 28 plus or minus square root of 28 squared, which is 784 minus 49 times 20, which is 980 over 10. So we will have 2x plus or minus square root of 784 minus 980, which is negative 196. That's square root of negative 196, so that becomes I 196 over 10. 196 is actually 14 squared, so I'll have 28 plus or minus I root I 14 over 10. Have 2 in common, so we have 14 plus or minus 7I over 5. Here we actually end up getting a complex solution. The moment you get a complex solution, it tells us that the system does not have a real solution. So since we have two complex solutions, we can still find the pair of solutions by substituting that. So I have x as 14 plus I7 over 5 minus 7, which would be 28 plus 14i over 5 minus 7. You take the LCM, you will have 28 plus 14i minus 35 over 5. Upon simplification, you'll get 14i minus 7 over 5. That will be the first part. And the second part would be 2 times 14 minus i7 over 5 minus 7. Distribute, you get 28 minus 14i minus 7. Take the LCM, 28 minus 14i minus 35 over 5. So the answer would be minus 14i minus 7 over 5. So the pairs are x is equal to 14 plus or minus i7 over 5, and y is 14 plus or minus 14i plus 7 over 5. Now, if you recall, for a linear system, the solution is the point of intersection of the two lines. So geometrically, we are looking for the points where the circle intersects the line. Now, since our solution is imaginary, we can conclude that the circle doesn't intersect the line. We can actually roughly sketch this out. Now the circle is of radius 1.414 root 2. So if we have plus root 2 and minus root 2, the intercept of the line is negative 7, because we have y is equal to 2x minus 7. Let's see, that would be 1 and perhaps 2 here. So when x is 2, the corresponding point would actually be 4 minus 7, that gives me minus 3. So I'll have minus 3, which is perhaps over there. So when I draw the line, roughly, you will see that the circle does not touch the line. So, which is why we don't get a real solution. So you have to keep that in mind. If you don't get a real solution, it means that the circle and the line do not intersect. They are geometrically apart. Okay, let's modify this example and perhaps come up with a better one where we have an intersection. Let's say 2x minus y equals 7, the same problem, but I'm going to change the radius. X squared plus y squared is equal to perhaps 64. Now I'll do the same trick. I'm going to take the linear equation, rewrite it, y equals 2x minus 7. Take this value, plug it in the second equation. Foil the second equation. We get 4x squared minus 28x plus 49 equals 64. Then you'd have 5x squared minus 28x plus 49 minus 64 equals 0, which would mean 5x squared minus 28x minus 15 equals 0. Now, again, we'll use the quadratic formula because this is a quadratic equation. So a is 5, b is minus 28, c is negative 15, and if we use the quadratic formula, we have minus of minus 28 plus or minus square root of minus 28 squared minus 4 times a times c, which is negative 15, over 2 times a. So we will have 28 plus or minus 784 plus 20 times 15 is 300 over 10. So we'll have 28 plus or minus 784 plus 300 is about 1084 over 10. So x has two solutions. One is 28 plus root 1084 over 10, and the other is 28 minus square root of 1084 over 10. And numerically, the two solutions would now be 28 plus or minus the square root of 1084, which is 32.92, divided by 10, which would give us 28 plus 32.92 over 10, and 28 minus 32.92 over 10. 28 plus 32.92 is 60.92 over 10, and the other one is minus 4.92 over 10. So we'll get 6.092 and minus 0.492. Those are the values of x. Now I could take each value of what x and plug it in y, solve for y. So then x is 6.092, y is 2 times 6.092 minus 7, which is 12.184 minus 7 should be 5.184. Likewise, when x is equal to minus 0.492, y would be 2 times minus 0.492 minus 7, which would be minus 0.984 minus 7, so I have minus 7.98, excuse me. That will be equal to minus 7.984. Now, what does this mean? The only difference between this problem and the other problem we first did is that the radius of the circle is now 8. It's not a pretty circle, but we have 8 and 8 and 8 and 8 of 8. We know the line had an intercept at negative 7, and it passed through 2, minus 3, perhaps somewhere over there. The line sort of goes that way and that way. So the first point is 6.092, which is the value of x. So that is 6.092. And the corresponding y value is 5.184. In the second case, when I plug in minus 4.92 or minus 0.492, the corresponding value of y is minus 7.984. Keep in mind that the picture is not drawn to scale. If you use a calculator, you will get a clear picture. So in this problem, we have a solution because the line passes through the circle, which results in 2 points of intersection. Hence, we have a real solution. If we had an imaginary solution, it would only mean that the circle and the line do not intersect. Here's another example, slightly different from the previous one. let's take y equals x squared plus 4 and y equals minus 3x squared plus 15. Now in this problem both the equations happen to be non-linear. So what do? Well, this is actually an easy problem. Now, if you look at it, this is the equation of a parabola. So is this. But the only difference is this is a parabola that is open up. That is a parabola that is open down. So clearly they're going to intersect somewhere if we have a real solution. So how do we find that point or those points? All we have to do is set one equation equal to the other and you solve. So move all the x's to one side. I'll get minus 4x squared is equal to minus 4 plus 15. Minus 4x squared would be equal to minus 11. The minuses would get cancelled. 4x squared would be equal to 11. X squared would be 11 over 4. We take the square root. We get plus or minus square root of 11 over 4. That is plus or minus square root of 11 over 2. So is 1.658. So I found x. Now I take this and plug it in and find the value of y. It doesn't matter which equation you plug it in. So you plug in 1.658 or you plug in minus 1.658, you'd still get the same answer. So we'll have 1.658 squared, which should be 2.75 approximately, plus 4, we'll end up getting 6.75. So when x is 1.658, y is 6.75. When x is minus 1.658, y is 6.75. What does this mean? Again, the first equation is a parabola open up like 4. The second is open down. So clearly we have this point and that point. Those 2 points would be minus 1.658 and minus plus 1.658, and the corresponding value in the y-axis right there would be 6.75. In this problem the two parabolas intersect, which is why we have a real solution. If the two parabolas did not intersect, the solution would be imaginary. Here's another example. So here we have a parabola and a circle. So you take the simpler one and plug it in. So let's take y, which is x squared plus 4, and plug it in the second equation. So I will get x squared plus 4 squared equals 64. Foil the second part. X raised 4 plus 4x squared plus 16 equals 64. X raised 4 plus 5x squared plus 16 minus 64 equals 0. X raised 4 plus 5x squared minus 48 equals 0. Clearly this sort of looks like a quadratic equation, but it doesn't look like a quadratic equation because of the fourth power. So when we use a dummy variable, u is equal to x squared, we will see that the first term is u squared, second term is 5u minus 48. Now we have a quadratic equation. Solution to this can be easily found by using the quadratic formula. A is 1, B is 5, and C is negative 48. We could use minus b plus or minus square root of b squared, which is 25, minus 4 times a times c over 2a. So minus 5 plus or minus square root of 25 plus 48 times 4 is 192 over 2. That's minus 5 plus or minus square root of 217 square root divided by 2. The square root of 217 is 14.73. So the two solutions for u are u is equal to minus 5 plus 14.73 over 2, and u is equal to minus 5 minus 14.73 over 2. So we'll end up getting 9.73 over 2 and minus 19.73 over 2. So the answer would be 4.865 and minus 9.865. But this is the solution for u, but we actually want the solution for x. So our initial substitution was u is equal to x squared. This would mean x squared equals 4.865, and x squared is minus 9.865. I can omit the solution right away because this will result in a negative, in an imaginary number. So I'll just stick to this one, square root of 4.865 to plus or minus square root of 4.865, which should mean I have two solutions. One is plus 2.205 and the other is minus 2.205. Since we have real solutions, this means geometrically the circle and the parabola do intersect. So that's my circle and the parabola that is open up, which is x squared plus 4, and the circle, which is x squared plus y squared equals 64. So that's 8 minus 8, minus 8. This is 4. The picture is not drawn to scale. You could clearly see the parabola crosses the circle exactly at 2 points, and the x value of the crossing is 2.205 and negative 2.205. And how do we find that y value? Then plug it in the equation of the parabola, so which is y equals 2.205 squared plus 4, and that would give us approximately, this is 4.864 plus 4, so it's approximately 8.864. So I plug it in the first one, I end up getting, 8.864. But if I plug it in the second one, I'd get y squared equals 64 minus x squared, which is 64 minus 2.205 squared. So y squared would be equal to 59.13, and the other would be, and the root of that will be 7.69. We have two solutions, but only one of them will work. Which one would it be? It clearly is not this. reason being, the radius of the circle is 8, which would mean the point of intersection of the parabola must be within the radius of the circle. In other words, the answer must be less than 8. So the first solution we got for y was 8.864 by plugging it in the first equation. It's not going to work, but when we plugged it in the second equation, we ended up getting 7.69, so that has to be 7.69. Again, you would not have a real solution at all if the parabola and the circle did not intersect. Sometimes the equation of the circle may not be explicitly written, in which case you'd have to complete the square to get the equation of the circle, and then solve in a similar manner like we just did with all these problems. So there are several other nonlinear equations that form a system, but to understand solving decimal nonlinear equations, these simple examples are sufficient. I hope you understood the concept of solving nonlinear equations. Thank you for watching the video.